MAT112 Chapter 2-2, page 2, going on to intersections and unions. So intersections between sets, that's the symbol for an intersection, where they overlap. I like to call those the ands, like where is it this and that. Overlap are good words. Unions means this or both, or things that are found in both sets. So this or that. All right, so let's go through the examples. Because these sets don't overlap, they're disjointed, therefore the intersection between the set A and B is an empty set. Okay, that was a lot of information. There, according to the picture, the Venn diagram here, neither of these sets cross each other, so there's no overlap. Therefore, the intersection of them is an empty set. Okay, and A and B are disjointed from each other. The sets have nothing in common. Okay. This one says the shaded area is the union of set A and B. So 5 is in both sets. 10 is in A or B. So all of the numbers here in this universal set, since there's none outside the sets, go in the sets. 10, 15, 5, 20, 30, 45. Didn't bother putting them in order, doesn't matter. 6. Sometimes when there's a lot of numbers, they don't end up in order. I just try to be visual about it. I could put them in order, but it's unimportant. And because there's none outside, then the universal set is an improper set of the union between A and B. I think you could say it that way. A, what's just A? 10, 15, 5, 20. Just B is 5, 20, 30, 45. Order doesn't matter. Let's go down. Shaded area here is the intersection. That's the symbol for intersection. A intersects set B here with 14 and 15, just the two. The universal set is all of them. And not A. Not A. Sometimes it's helpful to know what A is. And if you don't have a picture in front of you, I tend to make pictures, but if you don't have a picture in front of you, you can write down all that A is and look at the universal set and find out anything that is not in A. So like 10's in A, 12's in A, 14's in A, 15 is in A. So not A would be everything else, 13, 16, 17. Not B. What's B? B is 14, 15, 13, 16, 17. All of these. So not B is anything that is in the universal set that is not in B. Okay. The one at the bottom, let's see, let's start with the universal set here. So notice we do have some numbers, some members, some elements that are outside of set A and B. So we want to make sure we include them in the universe here. Universal. 3, 8, 11, 1, 5. It might be easier to put them in order. I kind of go by location sometimes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I always count, make sure I got everybody. I don't want one number being off somewhere. All right, let's see. All these things that they're asking me, I'd like to start with A. So A is 8, 3, 11, 1, 5. B is 1, 5, 9, 12, 15. You know what? It may be easier to put them in order so then I can see what's in there and not in there, but I'm kind of doing it by the picture at the moment. All right, this is the union symbol. Union between them means everything but 7 and 13. So here, let's try to match that below. So everything in A. Don't rewrite the 1 and the 5, 9, 12, 15. Just not the 7 and the 13. 1, 2, 3, 4, 5, 6, 7, 8. Right, 10 altogether. All right, not A is everything that's in the universal set that's not in A. Or you can look at the picture. 7, 13, 9, 12, 15, right? Everything that's not in B is 7, 13, 3, 8, 11. The union of A and B was all of these, and this is not any of those. So what's missing here between the universal set and here? Well, it was the U's that were outside. So this is 7 and 13. There is a rule that says this can be distributed, but you have to flip this. So the intersection of not A and not B, not A and not B. So you could draw pictures of what they are or look at the list, but that sort of confirms that these numbers are not in the intersection. Here, let me do that. Do a little picture. You have two circles, and the union of them would be all this. So the not that is all the U out here. Okay, that's just one way to look at it. All right, let's look at some other ones here. Oops, can't move it over. Intersection of A and B. That's what, 1 and 5. The intersection of not, I just did this here. So this is 7 and 13, right? What is not in A? What is not in A? That's everything out here and all of B, right? What is not B? That is all of A and everything's not. So see how both of these pictures have everything on the outside covered? So the intersection would be the overlap, which is the outside. Okay, everything else is only hit once. All right. The union of the knots. That means all of these and all of these written once. That one's even harder to do by picture, but see how there's a 7, there's a 13, there's a 3, there's a 9, there's an 8, there's a 11, there's a 12, and a 15. Remember, that's both not A and not B. Okay. Not A is these. B is here. We want an intersection between these two sets. So this is where writing them out comes in handy. I don't know that it would take me time to draw those and kind of process those. But if I already have a set that's not A and I have a set that's B, all I need to do is when it's an intersection is find where they are the same. So no ones, there's a 9, there's a 12, and a 15. Okay, so that's just over here. B is just these. So even though not A has these, B does not have those. So it's not an intersection. But a union does. So that would be all of these plus the 7 and 13. Okay.